Welcome to the Ruckus SmartZone Administrator Demonstration Series for the SmartZone OS 5 release. In this course, we will show you the functionality of SmartZone OS 5 along with the basic configuration of many aspects of the controller. In this particular video, we will provide you an overview of the SmartZone controllers, which include the virtualized as well as the appliance options. So let's get started. As mentioned in this module, we will learn about the Ruckus SmartZone controllers. We will also look at the controller network interfaces of the hardware or the appliance devices, and we'll look more specifically at the SmartZone hardware controller. Ruckus SmartZone controllers. Ruckus SmartZone controllers are wireless LAN controllers that run the Ruckus SmartZone operating system, which comes in two versions: the SmartZone Essentials and the SmartZone High Scale. SmartZone controllers are available in two deployment options, either as a physical appliance or as a virtual machine. The options are further broken down as follows: a SmartZone 100, which runs the SmartZone Essentials option, and the SmartZone 300, which runs the high scale version of SmartZone. From a virtual standpoint, you have the virtual SmartZone running the Essentials or the virtual SmartZone running the high scale. Whether you're deploying an appliance or a virtual, a high scale or Essentials, you will find the features and configuration options are almost identical across all platforms. However, there are some important differences to know and understand. You will learn more of these differences in the remainder of this module and the rest of the course. High-scale deployments typically are used in large-scale environments such as managed service operators or mobile virtual network operators, where a single instance or cluster can provide support for thousands of AP devices along with 100,000 clients with additional support when clustering is used. High-scale provides an additional segmentation by domain in addition to zones, providing an ability to provide segmented management and control of many clients while maintaining unique settings for each. High-scale is also designed to efficiently provide health reporting, traffic analysis, and logging to an external management applications like the Ruckus SmartCell Insight. Essential deployments commonly support enterprise, hospitality, education, retail, healthcare, and businesses in many other market types, including some small-scale managed service providers. Single nodes can support up to 1,000 APs and 20,000 clients, or 50 ICX switches. Network management and control functions are available along with health analysis and troubleshooting. Short-term reporting is also stored with the option to report to external services such as Ruckus's SmartCell Insight and other third-party applications. Although there are two virtual options, Essential or High Scale, both use the same software package and simply deployed with your preferred profile that fits your requirements. This table shows the differences in capacity between the Essentials and the High Scale platform. When it comes to functionality, the two profiles function much the same, with some operational differences, such as domains. This will be explained throughout the course. Clustering of the appliances or virtual deployments, regardless of the chosen profile, expand capacity of SmartZone while providing additional redundancy. The most important of the differences between high scale and Essentials is the structure. SmartZone high scale controllers are based on domains. Domains represent administration boundaries. SmartZone High Scale is designed for large-scale deployments, and you can create additional subdomains to which you can delegate administration. Subdomains will inherit a number of settings from the system domain. You can also create partner domains. Partner domain administrators have autonomy and control over operations and functions within the partner domain and can customize some settings rather than inherit them from the system domain. Partner domains are ideal for managed service providers and can themselves contain subdomains. Once partner domains and subdomains have been created, the next step is to create zones. Whereas domains represent administrative boundaries, zones determine the configuration and behavior of the access points. When access points first register to the controller, by default they join the staging zone in the system domain. Access points can then be moved to target zones where they will adopt the zone configuration and settings. SmartZone Essentials is based on a single system domain. As domains represent administration boundaries, there is a single point of administration, though you can add additional administrators with customized rights. To be clear, you cannot create subdomains or partner domains. You can, however, create multiple zones. Remember that zones determine the configuration and behavior of the access points that are members of it. When access points first register to the controller, by default, they will join the default access point group in the system domain. Access points then can be moved to target zones where they will adopt the zone configuration settings. Virtual SmartZone uses virtual machine hosted on an x86 server instead of a dedicated physical hardware appliance. A virtual infrastructure begins with server hardware. An operating system that will be later capable of running virtualization is installed onto the server. At the time this course was created, the support options are VMware, Linux, and Microsoft Windows Server. Once an operating system is in place, a hypervisor needs to be installed. Hypervisors manage the virtual machines. The corresponding hypervisors for this supported platform is VMware, which is natively integrated as part of the VMware OS, Linux KVM, and Microsoft's Hyper-V. The control virtual machine is then installed. This is the VM with its own operation system. It is also possible to install Virtual SmartZone on commercial cloud services such as Google Compute Engine, Microsoft Azure, and Amazon Web Services. Virtual SmartZone deployments require allocation of virtual resources within a server, which vary depending on the AP and the switches that are going to be controlled. High scale or an Essentials deployment can also affect the requirements. Virtual SmartZone is capable of automatically scaling to the supporting higher number of APs and clients if it determines at system boot up that there is sufficient CPU and memory on the virtual machine to support more APs and clients. Additional resources can be allocated to the Virtual SmartZone instance if needed, allowing for growth. The Virtual SmartZone appliance does require at least 100 gigabits of storage space. However, it can be deployed with a thin provisioned virtual disk, which can grow to the maximum size of 600 gigabyte. Because required resources vary depending on the number of AP and switches, along with the type of deployment, it is best practice to review the Virtual SmartZone Getting Started Guide to see what resource requirements are needed for your particular deployment. The Ruckus Virtual SmartZone also provides a hosted cloud-ready wireless LAN controller for service providers or enterprises, allowing for the offload of hardware management to cloud service providers while providing exceptional access. With cloud services, you gain flexibility, resiliency, and scale to your wireless LAN deployments. Virtual SmartZone can operate on the hosted environment either in high scale or in the Essentials profile. Virtualization is a complex subject with many variable factors, and a detailed look at virtualization is beyond the scope of this course. If you'd like to know more, you should view the Introduction to Virtualization and Hypervisors on the Ruckus training portal. Once the deployment platform has been decided, you will need to consider licensing. Licenses are required for the Virtual SmartZone controller, the Virtual SmartZone data plane, access points, ICX switches, and non-Ruckus GRE tunnels. Flexible license options give organizations the freedom to manage licensing according to their business needs. Licenses are available per access point, are cloud managed using Lyman, License Management System portal, and are transferable. The SmartZone controller syncs with the Lyman automatically once every 24 hours and can be manually synced and applies the licenses associated to your device. If you would like to know more, you should view the SmartZone licensing course on the Ruckus training portal. Let's take a look at the controller network interfaces. SmartZone controllers communicate over the network interfaces that are dedicated to specific communication types. They are found in the graphic user interface under the cluster settings and also are collectively known as the cluster planes. The four interfaces are management, control, clustering, and data. The SmartZone controller interfaces just mentioned perform the following functions. The management is the web user interface that you log into and is accessed via the management interface, as well as the CLI. Services such as SNMP, syslog, FTP are also communicate via the management interface. The control interface is for the access points that you deploy and will communicate to the controller over the controller interface, which is primarily via the SSH tunnel. Access point configuration changes are delivered to the access points via the tunnel, and reporting and statistics are also delivered to the controller. The cluster interface. Multiple controllers configured as a cluster will communicate using this cluster interface. This interface is used exclusively for cluster communications and requires good bandwidth and low latency. It is not recommended that cluster nodes are geographically separated. And the data interface. The data interface is used in limited cases where you want to tunnel all of the client data. The data interface is natively built into the SmartZone appliance. The virtual SmartZone-D, or data plane, is a separate virtual machine that provides the data plane functionality of a virtual SmartZone, both in Virtual SmartZone Essentials and High Scale. Deploying of the virtual SmartZone data plane offers secured tunneling to user traffic that encrypts payload traffic, maintains flat network topology, enables mobility across layer 2 subnets, supports point-of-sale data traffic for PCI compliance, and offers differentiated per-site policy control and QoS. Deployments of SmartZone in the cloud services, such as AWS, benefit from virtual SmartZone data plane as well as forwarding the traffic in a local environment if proxy or VoIP services are being used. In order to use the virtual SmartZone data plane, the initial controller is built, then the virtual SmartZone data plane is added as a separate virtual machine and configured to communicate with the controller. Once configured, the access point will establish a data plane tunnel to the virtual SmartZone data plane. A detailed look of the virtual SmartZone data plane is beyond the scope of this course. If you'd like to know more, you should view the virtual SmartZone data plane course on the Ruckus training portal. And finally, let's look at the SmartZone controller hardware. The Ruckus SmartZone 300 is a high-performance, high-availability hardware platform designed for large-scale critical carrier networks. The 2U rack mountable chassis opens from the front to allow access to the field replaceable fans and the redundant disk drives. The rear of the chassis contains the dual redundant hot swappable power supplies, the management, control, cluster, and data plane ports. The SmartZone 100 is supplied in two versions. For both, the rear is the same. It contains a single power supply, incorporated on and off switch, and if you switch the unit off, you must wait at least 20 seconds before switching it on again, and the redundant fans. The first variant of the SmartZone 100 is the S-104. The front chassis of the SZ-104 contains factory default pinhole, alarm LED, 4 gigabit Ethernet ports, the console port, and a power and LED activity lights. The 4 gigabit Ethernet ports can be set up in two ways, a one-port group or two individual port groups. In a one-port group, all of the interfaces are bridged and all management, control, cluster, and data traffic will flow through a single active port on the bridged interface. The interfaces are not a lag and do not aggregate the traffic. Only one port will be active, though others can be used for redundancy. In a two-port group, the first and second ports are bridged and used for management, control, and cluster traffic, and the third and fourth ports are used for data. The second variant of the SmartZone 100 is the S-124. As with the S104, the S124 contains the same rear and front features. However, the S124 additionally has two 10 gigabit SFP ports as well. The 4 gigabyte Ethernet and the two 10 gigabyte ports can be set up in two ways: a one-port group or a two-port group. In the one-port group, all of the interfaces, including the two 10 gigabit ports, are bridged, and all management, control, cluster, and data traffic will flow through the single active port on the bridged interface. The interfaces are not a lag and do not aggregate the traffic. Only one port will be active, though others can be used for redundancy. In a two-port group, as with the other controller, the first and second ports are bridged and used for management, control, and cluster traffic, and the third and fourth ports are used for data traffic, with the addition of two 10 gigabit ports. You will learn how to configure the port groups later in this course. To summarize, in this particular video, we saw the Ruckus SmartZone controllers, whether it be Essentials or High Scale. We looked at the controller interfaces, and then we looked in more detail of the interfaces and the attributes of the hardware controllers. Thanks for taking the time to watching this video. I hope you are able to look at the other videos within this series, allowing you more details of the Ruckus SmartZone OS 5 release. Thank you.